Welcome to another video from ExplainingComputers.com. This time we're going to build an entry-level PC with an Intel processor and graphics card. In the last video I discussed how and why I chose all the components. So let's begin with a brief hardware overview before launching into construction. At the heart of our system we have this Gigabyte B760M DS3H DDR4 MicroATX form factor motherboard, which at the time of making this video costs $109.99 or £91.97. And into this we're going to be fitting our processor, which is here. This is an Intel i3-14100F, which costs $90.09 or £72.97. And because this is an F suffix processor, it has to be used with a discrete graphics card. The card in question is this Sparkle Intel Arc A310 Eco 4GB model, which currently sells for $99.99 or £98.99. This is an entry-level card that's still capable of video editing and 1080p gaming, and was selected to keep the total system cost to $500. Turning to RAM, we're going to be fitting two 8GB Corsair Vengeance DDR4 memory modules, which come in this 16GB kit for $31.99 or £29.99. We also need a system drive, and here we're going to be fitting this Crucial P310 500GB SSD that currently sells for $41.99 or £39.50. And I find it amazing just how much memory and storage we can currently buy for these prices. Next, our power supply is this Corsair CX550, which has a price of $59.99 or £48.98. And finally, everything is going to be housed in a Gamdias TALOS E3 Mesh Gaming PC case, costing $59.99 or £52.99. All of the prices I've just listed are from Amazon in mid-March 2025. And, as I've said, I discussed component selection in detail in the last video. So, let's unbox our hardware, drool over its specifications where appropriate, and get on with the build. So, let's open up our motherboard. Very exciting, just comes up like that. There we are. Oh look, a SATA cable. We don't actually need that, but here is the board itself. Oh, there we are, look. Lovely thing this, and oh, it's in an anti-static bag which is sealed, but we can, I think, just ease that tape. Like, come on, let's keep the bag in nice condition. And there we are. We can get at the motherboard. Oh, crinkle, crinkle, and there we are, our new motherboard. Very exciting. But just for a second, I'm going to put it over there because there must also in here be maybe underneath. Yes, there is our I/O shield. But having looked at that, put that down over there. Let's come back to the motherboard itself, and we can see here its processor socket, its LGA 1700 socket. We can see we've got 4 DIMM slots for memory. Under here we've got our chipset. This is our B760 chipset sitting under this heatsink. And down here we have our PCIe slots, 2 PCIe 3.0 x 1 slots, and 1 PCIe 4.0 x 16 slot, in which we're going to be fitting our graphics card. We also have 2 M.2 slots that can both take an NVMe SSD, both of which are PCIe 4.0 4-lane. And as we can see, one of these slots is fitted with a heatsink, what Gigabyte call a thermal guard, and we'll be using this when we fit our system drive. Turning to the back panel, at one end we find 3.5mm audio connectors, 2.5 gigabit Ethernet, and 4 USB ports, 3 of which are USB 3.2 Gen 1 Type A, with the other being USB 3.2 Gen 2 Type-C. At the other end, we then have two USB Type-A USB 2 ports and a PS2 port. And then in the middle, we do have a VGA connector, an HDMI port, and two display ports. However, as we're using our 14100F processor, these cannot be functional in our system. Returning to the top of the board, we find four SATA ports, two here and two pointing out this way. We have 24-pin and 8-pin ATX power connectors for connecting our power supply. We have a CPU fan header and three system fan headers. We have an 8-channel audio connector. We have a connector for two more USB 3 ports and connectors for four more USB 2 ports. We have a reset button. We have connectors for RGB LEDs, which some people will like. And for good measure, we also have connectors for parallel and serial ports. And of course, we've got connectors for our front panel, so we can hook up the motherboard to the buttons and LEDs on our case. To make the motherboard happy, it needs to be fitted with a processor, so let's release ours from its packaging. We can see it on the top here, and if I bring in Stanley a knife, we can cut through like that. Open this up. Come on, doesn't want to open. There we are. There's always lots of packaging here. Let's see if we can get this out. Come on. There we are. Here is our processor. We just slide it out like that. Amazing. I love the new processor. Although the bulk of this packaging is for the cooler. Let's just open this up as well. There we are. We can see the cooler. We'll come back to that in a second. But back with the processor, what we have here is an amazing little piece of technology. Just look at the back here. 1700 pads to connect this to the motherboard. And in an Intel i3-14100F, we find four of Intel's performance cores, offering 8 threads, with a base frequency for the cores of 3.5 GHz, rising to a maximum turbo speed of 4.7 GHz. So let's open up the packaging to get out the processor, and to fit the processor we need to go back to the motherboard. There's a surprise, and there is a cover on the processor socket, and I've always removed these before fitting the processor, but in theory you're supposed to leave them in place until it's actually in, so for once I'll be good and do that. And so we'll open up the lever like that, open up the cover like that, and you might be able to see there's a little arrow down here, and this arrow is important because it will line up with a similar arrow on the processor. In fact, there's two. There's a tiny one on the corner there and also one on the top of the die. And so let's just drop this in place. It's zero insertion force, so there's no force required to put it in. And now all we have to do is to put down this cover on top, and that will ping off like that. I still don't like doing it that way, but I'm being good this time. And then we put down the lever, and our processor is now fitted in our system. So let's go back to our cooler. Doesn't want to be left out. Here it is. It's got a lovely copper base, and as you can hopefully see, on the copper base there is some pre-applied thermal compound. Every time I make a video about a PC build using a stock cooler, people say, you haven't applied thermal paste to the processor. You don't need to using a stock cooler because it's pre-applied to the cooler. So let's get this out like that. There we are. This is a stock Intel cooler. Oh look, it's got an exciting blue ring on the top. So we now need to fit this, so let's return to the motherboard, which, as you can see, I've now raised up on two small pieces of wood because we're going to be fitting the cooler when the motherboard is not yet in the case, and the push pins of the cooler have to go somewhere when we push them through the motherboard. And you may well find it easier to fit the cooler when the motherboard is mounted in the case, but I like to do it when it's not in the case, particularly when I'm making a video. So let's bring in the cooler. Here it is, and it can go any way around, but you need to think about where the wire is going to end up, and I think it needs to be there so the wire will nicely fit into the CPU fan header. So let's try and get this correctly positioned. You don't want to be doing this multiple times, and I think it's about there like that. That sounded good. Push down on one push pin like that, and it should click. Click your swine. There we are. I think it has clicked, and there, well, that one's definitely clicked. That one there, go in like that, and finally, there we are, clicked in. We are secured to the motherboard. So let's just connect the CPU fan header to its connector over here. There we go. and lo and behold, we have got a motherboard fitted with a processor and a cooler. Next, let's fit some memory. Our 16 gigabytes are the DDR4 RAM, two 8GB modules. So let's bring in a Stanley with a knife and just open this up like that and get it out. Always exciting opening up more memory. Don't quite know why, but it always is. Oh, there we are. There's our memory modules. And let's just get the packaging off the top. It doesn't want to come off, does it? Is it upside down? Probably is. There we are. Oh, you never know. I've got in. That's exciting, isn't it? So let's go back across to the motherboard, which offers 4 RAM slots in a dual channel configuration. We've got a grey channel and a black channel. And for optimum dual channel memory performance, we want to be fitting 2 identical DIMM modules into the same channel. And if you're wondering which channel do we use first, there's a little label down here on the motherboard. Let's give you a close-up of that. It tells us to use the grey channel first. So let's just open up the retaining clips like that, and bring in our first memory module. Here it is. And sadly, they always fit the way around where you can't see the lovely writing on that side. They go in this way around, they only go in one way around. It matches up with the base down there. And if we just put this in like that, go in, you little swine, there we are, and clips in very nicely like that. And we'll bring in the other one as well. Bound to go in straight in. It is, look, second one, much easier. And there we are, we've now got 16 gigabytes of RAM fitted in our motherboard. Greetings! Do you know what time it is? It's storage time. So let's get our SSD out of the box. I think we have to just go through like that. Come on, go through. There we are. Couldn't get in there for a second. I can never get in, can I? Store in my videos. Anyway, hopefully. Oh, look, there we are. Here's our crucial P310. Another piece of plastic, and can I get into that? We can. So let's go back across to our motherboard, where, as you may recall, we have an M.2 slot with a heatsink, what is called a thermal guard by Gigabyte. So let's take this out like that and remove the heatsink. And we now take our SSD. Here it is. It'll plug in like that and go down there. That is fine. And on the back of the heatsink, as we can see here, there is a thermal pad. So let's remove its covering film like that. And this hopefully means we can take this and put it in again like that. Put it down onto the SSD, and it'll all hopefully be pulled nice and tight together when we put the screw in like that. There we are. That's pretty good. We have now got our SSD fitted with its heatsink. Although before I finish here, I want to give you a slightly wider shot to include the second M.2 slot, which can also take an NVMe SSD. It's a PCIe 4.0 slot just like this one here, although the mounting mechanism is somewhat different. It's this thing here. And if I bring in another M.2 SSD just to show you how it would work, in fact it won't work at all with it like that. You actually have to take it out and flick this thing around like that and pull out the pin like that, and then you take your drive and put it in here like that, and you put it there and you put the pin in the top like that, and that's the way the drive mounts. And I'm not going to leave this second M.2 drive in the system, so let's take it out, although I did want to show you how you use this second type of mounting mechanism. Right, shall we open up our Gamdias TALOS E3 Mesh gaming case? I think we should. It looks very exciting. So let's grab, I think, somewhere from down here, Stanley the knife and open up the top. Lots of tape to cut through here. Lots of work for Stanley. Very exciting. Open up something so large. Don't normally do this on this channel, but there we are. This end as well, of course, like that. And oh yes, we've got in. Whoa, it looks exciting in here. You can't see, can you? Very exciting. I think I'm going to fail to open this on camera, so I'm going to use the magic of filmmaking to get this on the table. There we go. Let's just get off the bag. The bag doesn't want to come off now. Dearie me. I can never get into anything, but it'll come off. And yes, Whoa, this is our new case. We've got the tempered glass side. We can see our fans at the front and presumably one at the back as well. Yes, we can see a fan at the back. And if we take a look at the top of this case, we find its power switch, audio connectors, USB ports, and also a magnetic mesh covering the top vent. All very exciting indeed. So let's go in search of a power supply, and oh look, here's our Corsair CX550, which is waiting in this box, but it's just stored in this box. It has been unboxed previously. I've left the bits in here. There's some screws which are critical, but this has been used in a previous project. Some of you remember which one that is. Let's put that down on the floor. So this is all ready to go into our case. So let's go back to the case and take it apart a bit. First of all, we'll take off the tempered glass panel. There we are. Don't want to damage that. That's a good solid piece of glass, you know. Put that down there. And the power supply actually mounts down here. It actually is separated from the inside. It's got a grill there, but it's actually separated. So we need to turn this over to get to where the power supply goes, like that. And I need to take off, therefore, the other side. There we are. Always exciting going inside a new case. And as we can see, various wiring and things here, various parts we will need. Let's just detach these. There we are, lots of knitting for later. But for now, we want to put our power supply in here. So let's grab the power supply. Here we are. And the power supply will be fitted so it will bring air in through the base of the case and blow it out the back. So it's going to go down in here, although I think the best way to do that is to turn this thing so it's sitting on the base. There we are, that's where it needs to be. So let's now put in some screws. And there we are, we now have a case with a power supply fitted. Next, we need to prepare the case for the motherboard. And the first thing here is to make sure that the standoffs in the case that will hold the motherboard are in the right place. They're kind of difficult to see, they are black on black, but what I've done is to put these little temporary yellow markers in place so I know where the standoffs have to be. And in the pack of things that came with the case, there are some additional standoffs in addition to the screws which will screw into them to secure the motherboard in place. So let me sort out the standoffs. There we are, and I can now remove the little yellow markers. And the next thing to do is to return to the I/O shield that came with the motherboard, which unusually is slightly generic. We have to actually remove that piece of metal, and we also have to remove this piece of metal, because if we don't, it won't fit. There we are, that should be okay. So let's go back to the case where we can now fit the I/O shield. It goes in like this. They can be a swine, they can go straight in. That seems to go in pretty easily. That's very good. And so in theory, we can now fit the motherboard. It should match up with our I/O shield and with the standoffs in the right places. If I get it in, just be careful putting it in, and hopefully that seems to be okay. What's not matching up? Something isn't quite right. That has to be under there. The little bits to get matched with the I/O shield, but that is looking very good. So I can now take some screws and fasten the motherboard in. And there we are. It's starting to look like we're building a computer. So the next thing to do is to turn to our power supply connectors, which are here. They have to plug into the motherboard, down here for the 24 pin, down here for the 8 pin. So let's do that. First for 24 pin like this, and then the 8 pin like this. Next, it's the turn of these, which are the case USB and audio connectors, which connect in here for USB 2, here for USB 3, and here for case audio. Moving on, it's now time to populate the front panel header And on this case, we've only got these jumpers to add for the hard drive LED, power LED, and power switch. And so I'll add in the power LED and power switch together like this, and then add the hard drive LED as well. And if you want more information about front panel connectors, you may find useful my explaining front panel connectors video. Anyway, we now have all the wiring that connects to the motherboard in place. And as I put the wiring in place, I've been feeding it through the appropriate holes from the back to make it as neat as possible. And so the final thing we need to think about is the wiring for the fans, the one here at the back and two fans here at the front. And here things are slightly unusual, because I assumed when I purchased this case that each fan would have a standard fan connector to connect to one of the three fan connectors on the motherboard, and also to the RGB controls down here. But that is not the case. All of the fans here are wired together to connect into a SATA power connector. And let me just show you that. Let's just carefully turn this over like that, and we can see all the wiring on the back. And let me just pull together the connectors here for the fans. Let's have a closer shot of that. And here we have two of the wires coming out of two of the fans, which are not terminated in standard fan connectors. Instead, they go to this SATA power adapter to power everything. And this, of course, means we don't have speed control or speed monitoring on the fans, which is a bit of a shame. I guess it depends how noisy the fans are, whether that's a big problem or not. We will see. And of course, you could replace the three fans of this system with standard fans that do connect to the motherboard. And we also have here this, which is a connection from the top fan to a switch on the case, which can apparently be used to control the LED lighting, including turning it off. Oh, and we also have another connector. This can be connected to the motherboard to synchronize the fan LED lighting with the rest of the system. But I don't think I'm going to connect that. I'm just going to connect in the SATA power connector. So let's do that. And there we are. We've now got power for our fans. And it's worth pointing out that around this side of the case behind the power supply, there is a mount here for a 3.5-inch drive. And indeed, around this side, there are mounts for two 2.5-inch drives. Although for now, that shouldn't concern us most significantly, because right now, this is a computer without a GPU. Greetings! Shall we do our final unboxing? I think so. Let's open up our graphics card, and somewhere here there is somewhere to cut. There it is, like that. And should be simple. And there we are. Oh look, I've got in. Here's our card. Anything exciting in the box other than that? No. Oh yes, there is actually. There's a little bracket because this is a half-height card, and we could fit it therefore in a half-height system, or a system that takes a half-height card. Crinkle, crinkle. Come on, come on. There we are. Here is our card. This is our Sparkle Intel Arc A310. So let's go back to the case, where to fit our graphics card, we need to open up the clip on the end of the PCIe x16 slot like that. And we also need to remove a cover so the graphics card can actually poke out the back of the case. And before we can do that, we have to, on this case, open up this like that. Very exciting. And then take out the cover. There we go. And we can now bring in our graphics card. And what a lovely little graphics card it is. And I should have pointed out, on the end of the card, we have a full-size HDMI connector and two mini DisplayPort connectors, I guess because it can be fitted in a low-profile case. And it's also worth pointing out, this card only uses a maximum of 50 watts, so it doesn't need an extra power connector. But if you're fitting a larger graphics card, it often will need an extra power connector that comes from the power supply. But we don't need that here, so let's fit this into our case. Put it down into the slot like that. It's clicked into place. So let's put in the screw. There we go. And we need to put this back into place as well. And I think we've finished the construction of this computer. So we have now got to the moment of truth when we find out whether this computer actually works. Let's make sure our monitor is on like that. Is the monitor alive? Yes, it is. So I'll turn on the power at the back of this computer. like that and press the switch on the top. And oh look, we've got light on the fans. That's definitely working, things are alive. Processor fan is going round. There's no operating system on this machine yet, but I hope we're going to see a BIOS coming up on the monitor. We are! The computer works. It's always a relief when a computer works, isn't it? And let's just test the lighting. In theory, if we hold down the LED button for a few seconds, 1, 2, 3, oh, they go off. And do we cycle now? Oh yes, on. Different colours, I think. Yes, different colours coming up. And oh, and a cycling effect. Lots of exciting things we can do here probably. Yes, there we are. So the computer most certainly works. And so I'm now going to load up an operating system so we can do a few quick tests. Greetings! Here I am back again. I've now installed Windows 11 on the system, and I've also got the computer running with the side on. Very nice it looks, and you might be interested to know that the fans really aren't very noisy. Most of the noise you can hear from this system is from its stock Intel cooler, and we seem to get good airflow from the fans with very little noise, so that's good. Anyway, over here in Windows 11, let's take a look at the system. We can see here we are running our i3-14100F with its 16 gigabytes of memory. That's running fine. And I have installed Passmark on the system, and if I bring up the results here, we can see we have a Passmark score of a 5886, percentile 68%. We are well above the world average, and I don't obsess about numbers like these, but I will here just show you some of the footage from when the Passmark test was running. Particularly here we can see the levitating islands in the sky. Always good to see the levitating islands in the sky. The frame rate here was pretty decent. And if we speed on through, we then get to the floating jellyfish in space test. I do love to see the floating jellyfish in space in a video. And again, frame rate is pretty good. This looks okay. And if we again speed on, we get to the space battle part of the Passmark rating test, where again, we've got a good frame rate. And admittedly, it wants to run this test in 4K, and here we're running in 1080p, but even so, for 1080p, this looks fine. This system would be fine for basic 1080p gaming, and of course it could be improved if you fitted a more powerful graphics card. Anyway, whilst I don't obsess over all these numbers, I do take a keen interest in the speed of storage on a system, so let's just run up a Crystal Disk Mark, which I've installed here. Here we are, and let's run all of these tests. There we go, and these are powerful results. We are clearly benefiting from our PCIe 4.0 M.2 slot with a 4th generation drive. These are very good results. Although the main thing I'm interested in here is, can we use this system for video editing? So let's run up DaVinci Resolve, which comes up nice and fast on this system, as you can see. That's impressive, I think, on a system costing $500. And here I've got an edit to an Explaining Computers video, ironically created on a Linux system and now ported across to Windows. And this just works absolutely fine. This is really, really solid performance. It's worth pointing out that when I installed DaVinci Resolve, it was happy with my graphics card straight away. No tweaks were required. That isn't always the case with DaVinci Resolve. And again, all I can really say here, it works. We're editing 1080p footage here, but it's working absolutely fine. If I go back to the front there and we just play this. Well, I guess we would expect basic 1080p playback to be fine on a computer these days, but anyway, it works. I'm very, very comfortable with this. There is no doubt I could edit this channel very happily on this computer. And that is a good result. I'm very happy with the outcome of this build. So there we are. We've built our new 14th generation i3 PC, and I'm very pleased with its performance. Indeed, I find it amazing what we can do these days with a system based on an entry-level processor and graphics card. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.